Hello, my name is Pavel Mikhailovskii. I'm leading a research group at JetBrains called Project Ludwig. If you're curious, it's called so after Ludwig Wittgenstein. We are trying to explore new ways of doing software development, new ways of building software development tools. And I'm going to present our vision. Just to be clear, then I say our vision, I mean just our research group. I'm not speaking on behalf of the whole company. And many of the ideas are not really original and new. Our vision has been impacted or inspired by Smalltalk, and it all can be considered reincarnation or a new implementation of Smalltalk. Well, actually, this statement is quite controversial, and you may very well refuse to call it Smalltalk. Definitely, it is not a direct continuation of the line of evolution stemming from Smalltalk 80. As you know, in its first decade, Smalltalk was evolving very quickly, and its design has undergone a number of radical changes. So Smalltalk 80 was really different from Smalltalk 71 or Smalltalk 72. Many of the original ideas have been abandoned in favor of optimizing the language for the hardware it was supposed to run on. And we are trying to revise some of these decisions and to propose an alternative line of development. So our research is an attempt to reimagine or re-engineer software engineering itself. One of the key goals is to reduce the accidental complexity of the present-day software development stack. And to achieve that, we want to build the whole thing out of a carefully chosen set of basic building blocks, primitives, carefully chosen set of abstractions, which should be easy to combine together, easy to reason about, and importantly, easy to learn and easy to understand. We really want to build a language that can be learned, like it's the basics of syntax in a day. Another ambitious goal is to heal this great schism between the devotees of object-oriented and functional programming styles. And by that, I don't mean building yet another eclectic multi-paradigm programming language where you have the functional and the object-oriented part. No, I mean providing some kind of unified approach to programming, unified experience. And another big idea is that even if you have such a simplistic design of the language, still code is a complex data structure and needs to be treated as such. And the traditional approach, traditional way of doing that, you store code in big bunch of text files and continuously reparse, reindex them, do symbol resolution and all kinds of analysis, type inference, control flow analysis, etc. is just insane because you don't preserve that computational effort, you throw it away, you have to redo all this starting from parsing on every minor change. And we want to do something better. And in a sense, it's just a step forward comparing to the original Smalltalk idea of storing code in image files. So we want to preserve the internal structure. We want to preserve the symbol resolution information. We want to be able to store additional information such as inferent types, for example, or all kinds of metadata, and that should bring a lot of benefits. It should allow us to build better tooling. Should make many things really trivial because your code representation will be indexed by construction, so that should make many important refactorings very simple. It should allow you to have structural different merge. Things like go to definition or find usages will become really trivial. That should allow to have a very efficient incremental compilation workflow, many different things. And finally, the final consideration is that we are entering the AI age, and every new solution should be built taking that into account. And we believe that both the minimalism of the model, the simplicity of the model, and the structural representation of code should allow us for better quality coding, AI coding assistance tools for many reasons. Because the model is just simple. It's easy to reason about, easy to understand in a sense, but also because it's easy to provide the necessary context in this structural representation, and it's also easy to validate code generated by AI when you have this sample model and referential consistency. And this is just a little example of what I mean by the accidental complexity of the present-day software development stack. Before starting this research, I've been working on the Kotlin compiler for a few years, and this is an incomplete and oversimplifying list of function-like things in Kotlin. Well, Kotlin is a nice language, and some people may argue that all these things there for a reason, but we want them to be just one thing, a function. So then you think about all these design goals. Of course, it's clear that Smalltalk they have a lot of in common with the original Smalltalk vision. And Smalltalk is indeed a simple minimalist language applying the same set of design principles all the way down. It also brings functional and object-oriented programming together, because functions are first-class objects in Smalltalk, obviously. And it does have this simple minimalist syntax that fits a postcard. But is it really simple enough? Can it be made even simpler? If you look closer, you will find a number of irregularities and broken symmetries here. For example, the message precedence rules don't seem to be very logical. And there is a kind of broken symmetry between methods and blocks. They both do basically the same thing, but you will use different syntax for defining them, and return statements behave differently. Could they be just one thing? In this postcard example, we can see some hard-coded magic variables and constants like this context, Boolean literals, etc., and the self itself. The language has no interface types and classes integral type definitions with implementations. This is a big problem, I think. Traits somehow help with that, but still the Standard libraries, standard classes suffer from that problem. Meta classes add some meta complexity. I remember learning Smalltalk and meta classes were the first major obstacle. Like I was wondering why we need them and why no other language uses them, or if they are so useful, why don't we have meta classes? That can be possibly simplified. And again, this is one of the biggest problems is that classes tend to have too many and yet never enough methods. And if you look at, let's say, class integer, you'll find a lot of methods which don't really belong to the idea of an integer number. And that breaks, of course, violates the single responsibility principle, and I find it a major design issue. Yeah, of course, we recently got extensions, and it's now possible to extend classes, extend behavior without modifying the original classes, but the way they implement it makes them a second class feature, kind of like. So we try to fix these problems, possibly brought some new problems to the language, but this is our solution. So we want to have a really minimalist design of our classes. This is how we define true and false constants. We don't have like true and false classes. True and false objects are just instances of the abstract Boolean type. And as you can see, they only have two methods, toString and if. This is all you need. And all the other methods, behavior is implemented using regular functions, and that makes your classes really easy to extend. You can also see that here we use the same syntax for defining methods, standalone functions, and anonymous blocks with like lambda colon syntax. And if you don't have, if your method doesn't have parameters, you can omit the lambda. And the pipe symbol stands for function application, or method application, or message passing, or whatever you call it. And yeah, this example makes it clear that the syntax is basically kind of as expressions without parentheses, or an indentation-based syntax for as expressions. Again, you can see that the previously defined if statement is applied as a function. So it's if method. I'm sorry, it's a method, but it's applied the same way functions are applied. Yeah, a few more examples. You can see how you can define some useful functions in a very compact way. This is how you create a list of objects. Again, you see that you just comma is serves as a list constructor, and that you can create objects by just invoking the factory function, which is basically just your type definition, and providing it with the parameters. And the IDE can of course, provide you with some assistance here. So you get the familiar keyword experience, but you don't have to type the parameter names. And you see the inferent type here. Yeah, and you may like it, but the question is this really Smalltalk? How do I dare to call it Smalltalk? And this is a reasonable question, but let's look at some of what has been called Smalltalk historically. This is Smalltalk 71, the original vision, so to say. And here we can find a lot of very interesting things. We can find top level functions, and we can find pattern matching. We can find pattern matching methods. We can find a very interesting way of constructing data structures. So basically, you do some pattern matching, and then you return the captured result as a data structure, and then you apply some functions to it, again by pattern matching. Yeah, and you can see some methods like syntax. And it's really difficult to find proper words for everything here. And you can see a lot of different programming styles combined together. And this is Smalltalk 72, and you can see that again. This turtle thing apparently defines a class or something class-like, but actually it's implemented as a kind of pattern matching function, a pattern matching closure, which does pattern matching against the stream of incoming messages. And the idea of a message is different here from that of modern Smalltalks. Basically, every token is a message, and the object or the function or whatever you call it is free to decide how to interpret it. Again, Smalltalk 72, and this is how you define the for statement, function, whatever. Again, pattern matching and functional syntax. And this is one of the proposed Smalltalk 72 syntaxes. I don't know if it has been ever implemented, but I really like it. It's really neat and it's very close to what I've just demonstrated. So if all this can be called Smalltalk, why our little language cannot be? And you see a lot of different things here that you see the design of the language was really inspired by Lisp, and you can see that functional and object-oriented programming styles, methods and functions, objects and functions are mixed in such a way that it's often difficult to tell one from the other. So, and this is not a very the fact that you can define object-oriented programming within using just functions, using just closures, has been discovered a long time ago, and it can be summarized by this colon by Anton van Straten: objects are poor man's closures, closures are poor man's objects. And why poor man's? I think just because it was said about the language. It was said about scheme, and in scheme there is no objects are not like first class. objects things. So you still need to build them yourself. And in our language, we of course want to support them on a syntax level. So this is the recipe how to get your object-oriented programming within functional programming. So basically, an object is just a function enclosure that takes a message selector, like something identifying your message, and returns another closure, the method doing the actual job and handling the parameters. And of course, an object closure can capture and encapsulate some private inner state, possibly mutable. And classes are just functory functions that return objects. And if you think about it, it allows you to read object-oriented code in traditional object-oriented languages, even languages such as Java, in functional terms. So basically, the class syntax is just a syntax sugar for defining closures. And of course, the idea that method definitions are somehow stored in the class and belong to the class is just an implementation detail, a kind of low-level optimization. You don't need to think about it. You can keep your classes small because only polymorphic functions and functions that are responsible for encapsulation that work with your private inner state really need to be implemented as methods, and all the other functions can be just top-level functions and reused between different implementations of the same type shape. So you can still write your programs in more functional, less functional ways, and that's a matter of taste, style, and it basically amounts to how you handle mutation. Do you really want it to hide it from the site? And how you isolate side effects. Do you want them to be put out of the core of your system somewhere closer to the border or not? And do you treat method or functional arguments as passive, transparent values or as effector objects with their own behavior? Again, there is no big grand divide. You can adjust all these options separately, independently. It's just a matter of style. So we are just in the beginning of our journey. We are trying to shape this vision into a viable product formula. And we are really interested in hearing your feedback and what you think about it. Thank you very much.